And now, my friends, I hope you sit safe and are, are ready to be inspired by the wonderful companies we bring with us today. Jonathan, are you ready?
Good evening, everybody. Yes, let me. Look, thank you so much for having me here. It's a great pleasure to be here. My name's Jonathan. I'm the CEO at Univrses, and Univrses is a computer vision company based in Stockholm. You can see there the picture of the city. There's lots of yellow vehicles. The reason they're colored yellow is because Univrses develops software to give these vehicles perception capability. And we do that by processing data from cameras on board those vehicles. We don't care if it's a bus or a forklift truck or even a drone. We can solve three problems for those moving vehicles. We first of all process the images from the camera to determine those vehicles' position, where they are relative to their surroundings. We also measure the 3D structure of the world as that vehicle travels through it, the 3D geometry just using the images from the camera. And we also determine the semantic nature of the world as that vehicle travels through there. So if it detects a lump of something on the right-hand side, is that lump a park bench? In which case that park bench is probably going to stay still, or is it a dog? In which case that dog might run out in front of the vehicle. And the vehicle needs to know that in order to behave appropriately in the context of this vehicle. So we work a lot with organizations like Zenseact, Volvo Cars, to help make their cars be autonomous. We work in other domains like mining, domestic robots as well. But what we're starting to do now is work within smart cities. And here we're taking our computer vision technology and we're squeezing it down to run on a smartphone. And what that means is we can put that smartphone into any vehicle, a taxi, a bus, a garbage truck, and not to make that vehicle autonomous anymore, but just to turn it into a data harvesting agent. So we run our computer vision technologies on the smartphone in the dash of the taxi, and we start to get information about the environment, where there's potholes in the road, where there's traffic signs that need to be repaired, where there's vehicle flows and pedestrian flows. Again, not to make the vehicle autonomous anymore, which is what we have been doing, but just to help manage the environment in a better way. And all of that data is then streamed up to a cloud and back down to a dashboard where the cities can use it and make better decisions. So we've started to work with traffic circuits, we've started to work with Stockholm Stad and other cities around Europe as well. Again, all using computer vision. This is the type of information that we can start to detect using our cameras. Over on the left-hand side, you have how to manage the environment where there's snow and ice. Then a little bit further over where there's damage to the environment that needs to be repaired. We can start to detect things like parking spaces. Of course, that's going to be very useful to you and I as these taxis and these buses drive around the city. They can infer where there's free space and feed that back to drivers like you and us. And then things like roadworks. It's a huge problem here in Stockholm. There are 4,000 roadworks in the city each year. They know exactly where they should be, but have absolutely no idea where they are. So if we can start to feed back that information, that's really valuable. They can start to enforce contractual obligations, ensure that they disrupt the flow of traffic in a minimal way. So we're already detecting some features, and we have phones out on taxis now in Stockholm. We're deploying in Zurich and Helsingborg later this month, and other places as well around Europe. Pretty soon we'll be bringing on board parking and other features that you can see there. I think what I'm going to try and do now is it's really nice to tell you, but it's also just better to show you. So here's a video of some of our technology that we're going to do. So there you go. It's the smartphone being put into any vehicle. This is actually a hire car, but it could be a bus or a taxi or a garbage truck. It's an app that processes the images from the smartphone out at the edge. There we're detecting the roadworks. So our deep learning networks are running out on the phone at the edge. So we're just streaming the location of the roadwork, the location of the street damage to the dashboard. There you can see the car traveling around the city. Where it's more red, it's worse damage to the road. And where there's the little trike sign is where there's the roadwork. And you can start to see now the deep learning working out on the edge on the phone, detecting all of the different street damage. We also blur out faces and license plates just for privacy reasons as well. We also run our positioning technology. What you're about to see now is where we're just using something called SLAM. We just detected using the images in the bottom left-hand corner to detect the 3D structure and the position of the car as it travels through that 3D structure. We're doing that out on the car. We can then build up this map of the environment that you can then see there. We can also do that in a dense sense, so we can do that in a rather than doing it based on features. We can do it on per pixel. So again, just using the images from the car, we can build up that 3D structure as the car drives through the environment. We've already done this in the autonomous car space, and we're now bringing it to the phone. This is another view of the same technology. There you've got the red line is the vehicle traveling through space, and we're building up that map, that 3D structure in real time as the car travels through the world. This is some of our more recent work. Is actually multitask learning. Typically AI is only very good at one thing. Here we're doing semantic segmentation. So blue is cars, pink is the sidewalk, green is the foliage. We can flick a switch, and with the same AI, we can now do depth inference. Blue is far away, yellow is close. And of course, these two things then can be combined to give better information to the city. Then we bring it all together. You can see in the bottom left-hand corner there, we've got the bounding boxes, the deep learning detections. And then in the LiDAR point cloud, we're detecting the parked cars. We're just placing everything in a map so that these can all be seen by the city. You can see the last detection is a red car in a bus stop. That's illegally parked. And we can detect that. All that information flows through to the city and is placed in a map to help them make decisions in a better way. So these phones are being placed now on vehicles now out in the city, taxis, garbage trucks, all sorts of other buses, all sorts of other vehicles, and we're starting to feed this information back to city municipalities and road transport authorities. But of course, it's not just cars and not just buses. There's this new wave of micromobility, and so here being a smartphone, we can put that on bikes or even e-scooters. So here's one of our more recent work. Again, you can see this is a phone attached to an e-scooter, and we can run the same computer vision because we're doing it all out at the edge. There we're semantically classifying just to get better information about what's in the city. But we can also start to run other algorithms as well out on the phone to provide value to the scooter rider, more indeed to the operator of that scooter. In this case, it was Boy. So here we're running our visual odometry to infer the position of it. One of the big problems that scooter companies have is they lose all their scooters because GPS is not a very accurate positioning system. You've got the depth inference as well that can provide some kind of form of collision avoidance, perhaps for the scooter rider. And then we can bring that all together to help provide information to the city as well. So that was a brief overview of what we're doing here at Univrses. I hope you find that interesting. If you have any questions, give me a shout.
Great, thank you so much, Jonathan. Excellent. Let me see. Now we don't have any questions, but I can give you one. Since we have some investors with us in all those meetings, so what's the kind of state of your company?
So we've grown to about 40 people now, based here in Stockholm. We've got active engagements with autonomous car companies, with companies like ABB, other large Swedish corporates. We generate revenue, we're profitable, but we're reinvesting these retained earnings in developing this new technology. We are considering raising capital perhaps later this year, but for now we are establishing product market fit, gaining early traction. And then once we do that, we've proven the market, proven the business model, we may well look to raise capital to accelerate.
Brilliant. You have a plan. That's great. I think we stop there, Jonathan. Thank you so much. And
Very good.
Good work.
Thank you very much. Nice to see you all.